Hello there, it's Jay here from Jay's Vintage Junk, and today, well, I was looking on my YouTube analytics and what have you earlier on, and I suddenly discovered I've passed the 2,000 subscriber mark. Then actually I noticed someone had sent me a message a few days ago to say congratulations that I'd gone past the 2,000 mark. Now I wasn't actually planning on doing a video this week. I've been working on the my new space. I've got a fair bit done, to be fair, but I'm a little bit shattered. Like I said, I've been really working at it. But I thought I've done 2,000 subscribers. I'm kind of blown away about that, really, because yeah, there's 2,000 people out there who want to look at the rubbish that I do. So what I thought I'd do. If you remember from my gold barn video, this is one of the two radios that I picked up for £1. If you remember, we did plug it in and we got it to hum and buzz a bit, but that was it. It was dead. So what I thought we'd do in this video is we'd actually see if we can get this old Cossor to play. And what I'm going to do, just for the fun of it, all I'm going to use to see if we can get this radio working, apart from the normal, screwdrivers, soldering iron and things like that, is test meter and a mobile phone. That is the only diagnostics equipment I'm going to use, just to show that you can actually get a radio like this working without loads and loads of test equipment. I've got signal generators, I've got signal tracers, you name it. You don't need them all, especially with quite a basic AM only radio like this. We should be able to get this radio to play, and I'm not going to completely restore it in this video. I just want to see if I can get this radio to play. And like I said, all we're going to use is basic multimeter, obviously soldering iron, basic hand tools, and a mobile phone. Right, what I'll do, I'll just reset the camera so we can actually look at the radio a bit better, and we will crack into this. So back in a sec. Okay, right. First thing we want to do is we want to get it out of the cabinet. We want to see what state the chassis is in, and we want to see what work has been done to it in the past. I believe it has probably been worked on in the past, being the fact that it's got that isn't the original mains cable there. So someone has obviously been at it before. So we'll just have to see what their work is like, and then find out why the radio is no longer playing. So as we'll assume that it was playing after the work previous had been done. You cannot always assume that. Radios have been got at before, as in someone's attempted to repair them, made the situation a whole lot worse, and then just giving up on it. I have bought a few sets in the past there. They have been got at. We used to call it the Phantom Dabbler. I believe that was an old like radio workshop term, and someone else had got in there and had a fiddle before. They used to be referred to as the Phantom Dabbler. Right, that's the knobs off. These are rather nicely well made sets. In fact, if you're looking for your first radio to restore, one of these very early 1950s Cossor melody makers, especially the AC model, this is an ideal first radio to restore. They're fairly simple. They've got a nice, easy to work on cabinet if you want to do a little bit of cabinet work. I think they do actually make this in a Bakelite cabinet as well, if you like polishing Bakelite. You've got an AC transformer, so it's quite a safe set. Right. Now, right, let's see about getting the chassis out of the cabinet. Tip that forwards. Oh no, I don't need to take that bottom off. We can take these out and take the chassis straight out. The cabinet on this one really isn't bad at all. There's a little bit of damp to it, but it's quite nice, this cabinet. A little bit of damage on the top, which I will try. Not obviously, like I said, I'm not going to do anything on the cabinet. I'm probably not even going to restring it in this video. I believe when we tried it, we couldn't get the tuning dial wasn't working, so it's going to need restringing. I don't think I'll do that in this video. Like I said, I just want to see if we can get it to play, and we can do more work on it in the future if we want. Right, let's extract the chassis. Okay, let me just get the cabinet stood up there. Right, I can see something slightly weird straight away. Someone's definitely been in here. The tuning doesn't actually work, amazingly. I can tune the radio. But that looks like a rubber drive belt. Yeah, someone appears to put a rubber drive belt. Obviously the tuning string's broken. And instead of restringing it, now we all hate restringing radios, but all they've done is they've put a rubber drive belt between the tuning spindle and the drum. So yeah, it tunes, it works. Does that mean that the actual tuning dial's missing? Yeah, unfortunately, the entire tuning, it should basically have a metal tuning dial that runs across, which then runs on some strings, up and down. Or the pulley's still there. The pulley's there. There's a pulley there. Ah, right, so this one, it's crossed. No, this one goes across like that. It doesn't go up. Some go up and down like that, some will tune across. This would have obviously gone across like that, but it's completely missing. There's no sign of it, so we would, obviously to get this radio right, we will have to make a new tuning pointer and completely restring the whole thing. I'm not worried about that for now. We can tune it with, yeah, I've never seen that before. I've seen some kludges in radios before now, but I've never seen. I don't know if we can make this out on the actual camera. Let me see if I can zoom you in a bit so you can actually see this. This is impressive. Look there. It's actually a rubber, and if I turn the tuning, you can see it does actually work. But obviously, like I see, you've no station marker or anything. Right, with that in mind, that's a very well used valve there. With that in mind, let's just tip the chassis up and we see, can I get this so you can see in there? It really looks like, no, let me get that zoomed out a little bit so you can, oops, so you can see better. There we go. Well, it hasn't been recapped, I can tell you that. It's still full of wax paper capacitors, so no one's done any recap work on this. The mains lead is, I suppose it's okay. There's no strain relief on it at all. I believe that's what that might have been. There's no strain relief on it, and it's just a 2-core. Oh dear me. Let's just see if I can get you in here. Right. Whoever worked on this radio, whoever repaired this radio, it looks like they didn't even have access to a soldering iron. Look. the new it's actually twisted on. Oops. Yeah, the mains wiring is actually just twisted. Yeah, it's just twisted around the terminals. Wow. Yeah. It wasn't even soldered. Right, okay. I think we're going to address that. Let's get this this mains lead out of the way, because we're not going to be reusing that. It's too short anyway, really. Could do with a longer one on there. And it could really do with this being a AC set with a mains transformer. There's nothing at all to stop us using a 3-quart cable and earthing the chassis, which will just add a little bit to the safety. In fact, that's horrible and sticky. Let me just get some snips and I'll cut that off rather than mess about with it. I was using the tools down at my car earlier on today and I can't find anything. Where's my big snips gone? Right. There we go. Oh, it's actually a 3-quart cable. So they used a 3-quart cable, twisted it on, and then didn't bother trying to find anywhere to twist the earth on. Let's get that out of the way. Even left the little how to wire the plug tag on. Left the how to correctly wire the plug on there, and then omitted the earth and twisted the live and neutral into position. That's great. Right, so we're going to need a new mains flex for it. That's a given. And we're going to have to... Well, we're not going to change all the capacitors, I don't think, at this stage. But we will need to test. A few of them. Specifically, the capacitor that is on the output valve, on the grid of the output valve. Because if that capacitor fails, it can take out the output valve. It can take out the output transformer, which we really don't want. Let's get you zoomed out a bit again. There we go. Right, let's see what we've got valve wise. In fact, wear my glasses so I can actually see things. There they are. Right, so we have a now, unfortunately, Cossor did use their own numbering system for valves, which I'm not familiar with. This is coming up as a 66KU. Now that is either going to be the output valve or it is going to be the rectifier. And this valve here, again, this is either going to be... I'm not sure because the actual printing's worn off that one, unfortunately. But it is... No, it's not readable. What I might have to do is actually pull the service data for this chassis just to know what the valves are. Let's see what we've got here. A 62 DDT. So it hasn't got all its original Cossor valves in it, as far as I can see. '62 VP. And we have a 62 TH. So it has got a full set of its original valves, well, original Cossor branded valves anyway. Right, now we've got to figure out which one of them is the output valve and which one of them is the rectifier. There's been some work done up there as well, not very well, but at least they've used a soldering iron in that time. electrolytic capacitor there. October 53. Right. I thought this radio was a little bit younger than that. I thought this radio was about 1950, so I wonder if that's a replacement. In fact, the solder tag on there doesn't look original. I think that might have been replaced at some point. Fortunately, we have very, very few waxes in here. We've got one there. In fact, let's find which the output valve is. That's going to be the rectifier there, which it is. So that big valve at the top there is the rectifier. This must be the output valve there. So let's have a see what's... That's coming off the output valve to ground. If that is short, that's going to cause some major issues. So first thing we'll do, let's test that capacitor there. I won't dig the circuit diagram out unless I actually absolutely have to, just to show that you can, generally speaking, especially on these really simple AM sets, get them to play without actually needing. Let's set that to 2 megs. Without actually needing the service data. Let's see if we've got a short on there. Oh yeah, look at that. So that's first capacitor there we need to change. In fact, what we're going to do, we'll put a new mains lead on it. Yeah, we'll stick a new mains lead on. And then we'll go through these capacitors and we'll try it after every capacitor change. We're going to start with that one because we know that's short circuit, that capacitor. That's definitely shorted. So we'll pull that out. We'll find out what value it is, and we will change that one out. I'm going to need a new mains cable. Now, in fact, if you just bear with me, folks, I will go and see if I can find something we can make a new mains cable with. So I can get you out a little bit and up a bit. Yeah, we'll see if we can find something we can make a new mains cable. We'll get that earthed up properly because that's just horrendous the way it's been left. That's an earth there. So what I'm guessing that's a ground there. Screen, yeah. HT start, HT finish. Oh no, that's them ones there. So yeah, that is just a ground there. I believe that's another ground there. The way that this that'll be filaments, won't it? Heater tap there. Right. Bear with me a second, folks. I will. I'll go and see if I can find a piece of 3/4 so we can put a new mains cable on it, and we will start having a look at some of these capacitors. So back in a sec. Okay, we're back, and I've had a rummage, and I found a cable. It's actually the old mains colour cord. I think I pulled this off an old radiogram that I was breaking up for spares. But anyway, I've just checked the plug. We've got a UK plug. I would have to change that out if I was ever to sell this because it's the old-fashioned style without the isolators on it, but that doesn't matter. 3 amp fuse in it, and we've got a 3-core cable. Like I said, this is the old UK colour code. Doesn't really matter in this application because this is the colour code that would have been used when this was produced. We changed our colour code, I think it was the early 1970s, it might have been around 72, 73, sometime around there, to the blue and brown. Before that we used red, black and green. Anyway, we'll stick this in. This is going to be better than the cable that was on there anyway, just by the sheer fact we've actually got an earth. Well, the other one had a earth, it's just they hadn't bothered using it. And it was too short. This is a reasonable length. Now, it's not the best thing to do to have to knot it like that, but in this instance there's not a whole lot we can do to hold the cable, so that's better than nothing, basically just putting a knot through the cable like that as some form of strain relief. Right, and we will also change the wiring ever so slightly, because this radio is wired with the switch in the neutral, which I'm not a big fan of. I would rather have the switch in the live side. So we will go there. Right. Yeah, that's right. So that's our input. So we'll go brown, black to there, and we'll go red to over there. And obviously then we can connect the earth in when we get to it. Right. Let's strip these wires back. I don't want to have them too short. There we go. We'll do the same with the live. And we'll do the same with the earth. There we go. Right, let's see, now where are my glasses? There we are. Right, so I've still got some of the old original wire actually wrapped around that terminal post there. We need to get that off. Sorry, I keep getting my head in the way of the shot, don't I? This is one of the great things about when I've got the new room sorted out. We'll actually have decent shots where that's not going to be happening. We may even have more than one camera angle, if I can find my other camera. So I've got a JVC camera that's the same resolution as the one that I'm using here now, but the audio's terrible on it. But it would be fine for it would be absolutely fine for a second shot. Now where's my solder gone? Ooh, and you get a shot of my big head while I get my solder out. There we go. And really I should be using my thicker solder for this. This is a bit of a waste using this really thin stuff, but we'll be alright with it. We'll tin these wires up. There we go. Tin that one up. There we are, on the earth. There we are. Right, now take that neutral there, and we'll bend that around that tab, and then we can solder it into position. There we go. Do a bit of a mechanical joint first, and then we can solder it in place. There we are, that's the first one, that's our neutral done. That's nice and solid, yeah, good solid joint there. And then we will connect our live up. I think we can actually get the live wire through the hole in the connector there if we warm that up slightly. Get that earth out of the way so we don't melt it. There we go. I'll go get that through a bit and we'll bend it back round on itself now. There we are. Bend that back over on itself. So we've got a good mechanical joint on the connector, and then we solder it in place. There we go. Right, and obviously we've still got the earth there which will connect to that point there. After we've pulled this capacitor out of the way, let's get that lot up there. That is obviously our heater, I think. Push that down there, out of the way. Right, we need to address this capacitor here, which is not looking very happy. Let's snip that there. We'll snip it there. We've got a bit, basically we've just left a little bit of the wire exposing which we can connect the new capacitor to. Let's find out what value this capacitor is. It's a 0.01. Right, at how many volts? Should be about 1,000 volts. Right, okay. 0.01 at 1,000 volts. I'll get my my capacitors. These are all my high voltage capacitors I use for valve stuff. And I've just noticed there's a few values I'm a little bit low on. But we do have a 0.01 here. Which we can put in. Yeah, I'm going to have to do a little bit of capacitor reordering, I think, because I'm very, very low on that value. Let's see if I've got any that I haven't used. 0.22. That's 0.001. No. Oh dear. Looks like I'm going to have to put a new another order of capacitors in, because unfortunately I am getting very, very, very low on that value. Anyway, we will pop this in there. Because as we saw before, this capacitor that we've taken out is very leaky indeed. I don't get anything on it now. Right, let's put this in there. Basically what I'm going to do, where's my other snips? There they are. I'm going to make a little hook with the wire that I snipped off there. I'm going to make a little loop on this lead. I'll cut this short. And this is known as J hooking. So you see I've got a little, basically made a little J there. I've got a little eye that I formed on the old cable there. We hook that through there. And we basically just squash that one down. We squash that one down. So we've got a mechanical joint between the old leads. And many times you'll do a lot less damage to the radio doing it like this than you would actually desoldering it from the tag of the valve holder, because you risk actually snapping off. Sometimes it's inevitable, there's not enough room to do this and you do have to, well, you can get in easily, like I say, if there's only just one and it's easy to get off, fair enough, but when it's right down there it's a bit of a pain. Just J-hooking the leads on like that and then soldering it into place, you'll actually make a slightly neater joint, and you'll risk doing less damage to the radio. I just want that to sit up there while I solder it, and then I can bend the rest in place. Get it up there. Let's solder it first and then we can move it into place. There we go. We'll bring that up. We will solder it to that tag there. And in fact, actually, at the same time, we can bring that earth round. We can solder that to the same tag. Like I said, then at least the chassis is definitely earthed. So let's bring that cap up there. And that round like so. Get in there, you little sod. There we are. Let that twisted round there. We can solder the earth on at the same time. Let's get that in there first and then we'll solder the earth on. There we go, that's that on. Let's get the earth in there. I'm not happy with that. I want the earth, a decent connection for the earth. Obviously it is safety critical. This iron's really a little bit small for soldering to a chassis like this, but there we go, we got away with it. Because there was already a point that had been soldered there, it wasn't too bad to do. We'll just snip this excess off there. That bit that's come through the back there. Right, okay, lovely. So we've actually got, the chassis is actually earthed now, which it wasn't before. We've got a new mains lead on. We've changed that capacitor. Now there should be, if I am correct, another capacitor coming off the output valve to the rest of the set. Off the grid of the output valve to the rest of the set. So that obviously wasn't that capacitor, because that capacitor went to ground. In fact, I wonder if that was on one of the heater legs. Well, no, it wouldn't be because that's AC, so that would bring AC straight to ground. So there must be DC on there. And the other capacitor we are interested in, we've got this one here. Alright, let's check that. That's okay. Now that seems okay. What what I will say is we will probably test these with the power on as well. I'm just doing any... You can get a good idea of a fault. If the capacitor is dead short, just on a meter like this, cold, then you know that capacitor is going to be bad. That seems to be a capacitor charging up. That might be alright. To 200 k ohms. I've got about 30. That's obviously capacitor charging, so that seems okay. I just wish I could quickly spot the grid stopper on the output valve. That's bias. The capacitor I'm looking for basically it stops the HT getting between the previous valve onto the output valve, and if it goes leaky, basically it turns the output valve on hard, makes it draw far too much current, and will damage the output valve, can also possibly damage the output transformer. Neither of which now is going to be a happy place to be. You can't just nip down to your local radio spares shop and pick up a new output transformer like you would have been able to do in the 50s or 60s, or even like into the 70s. Big dog bone resistor on the back there, that seems okay. Now where is that capacitor hiding? It's the only, basically it's the only one that I'm really concerned about at the moment, that I really want to test. If I can't find it straight away, I'll have to resort to actually getting the service data for this out and finding it that way. That goes to ground there. I'm guessing that's heaters. We've got parallel fed heaters on a set like this. Right. Is that a heater winding there? Yeah. And then they come off down there. That's okay. It's a really weird design, this radio, because you've got the smoothing capacitor on one side of the set and the actual rectifier right on, as far away from the smoothing can as you could ever imagine, really. That's coming out of there into there, which is that IF can there. So that's HT there. Alright. And the other side is someone's definitely fiddled with this radio in the past by the look of it. That's your HT there, the two red wires, then that one there is one of the filaments, That's the other filament there. And those two are the filaments, that one and that. Yeah, those two are the filaments. So, I'm sure someone's fiddled about with this. Yeah, that's not right. Yeah, I think someone's fiddled about with this radio, because that doesn't look right. I think I am going to have to get the circuit diagram out for this, because that doesn't look right to me. We've got our two heater wires. We've got our two... That's our HT there. The two red wires are our HT. Or is this... I'm wondering, is that the right transformer? Has someone changed this transformer out? No, because it fits right. It fits in the... it seems to fit in the chassis right. But then when we have a look under here... HT tap. So that's centre tap for the HT, which has been taken to ground. HT start, HT finish, which both end up over there, so that's our high tension. Going to the rectifier valve, which is right. Ah! Now I've figured out what they've done. Right, basically what they've done, the rectifier valve has got its own filament. It's got its own winding, its own tap on the transformer, just to feed the filament of the rectifier. Then the rest of the... so why on earth is... If that's the second to there... Okay, this is a weird radio. I am going to have to go and get the circuit diagram for this set, so I can figure out what the valve numbering is and figure out how on earth they have done this, because this seems quite strange to me. So we've got two low tension taps on the transformer. One of them is being used to just feed the rectifier valve. The other one is being used to feed the rest of the set. So is that directly heated? That's weird. Yes, this radio is not quite as simple as I first imagined. I'm going to have to pull the servotator out for it and just make sure that's how it should be wired, or has someone changed it and bodged in a different transformer, because all the soldering work round the rectifier up there doesn't look factory, it doesn't look original, compared with the wire, some of the soldering on the rest of the set. Someone's obviously been in here and fiddled about. And I'm wondering whether, in fact, the other thing is that the insulation on this transformer, there's nothing wrong with it, it's still fine, but that looks a lot older than the insulation used everywhere else in the radio. This is all PVC as well. This is the old cloth covered insulation. I will dig the service data out for this, and we will have a look, because I have a feeling someone swapped in a different transformer for it. I mean, it should still work. Yeah, because we've got a 6.3 volt tapping at 1.65 amps there. And we've got another 6.3 volt tapping at 0.6 amps there. Now, I've seen that before, but the small tapping like that has like been used for the dial bulbs or a separate tapping for a rectifier, but 0.6 amps seems very, very low. So what I'll have to do is find out exactly what that rectifier valve is, find out what the current draw of that rectifier valve is, and see if that's actually going to be enough to supply it. If not, we might have to possibly look at doing a solid state rectifier on this. I'm not sure if that's going to work or not. This radio has definitely been in the hands of a dabbler, someone that's yeah, they've well, we'll find out. Let's see if we can find out whether that is the right if it's not the right transformer though, it were a bloody good fit. Anyway, I'll go and dig the service data for this set out and we'll be back in a sec. Okay folks, I dug out my radio and TV servicing. This is the original volume 1. Unfortunately, in volume 1 we have the Cossor Melody Maker models 500 and 501, this being a 500, and this answers some of our questions. The good news is that that transformer is correct. It should have 2 filament taps. One is purely to power the rectifier. The other powers the filament bulb and all the filaments, sorry, the dial light and the filaments in all the other valves. So we're good there. I've ascertained which capacitor we need to look at. It's C25 there. That is the suspect capacitor, which is a 0.1 UF, and we will find it off the volume control. So let's get back to doing some diagnostics. I'm glad to see that we are actually we do actually have the correct mains transformer in there. That is good. So no, essentially it will be, that's volume, isn't it? That one. That's tone. On tone, I think. So this is the volume. I think that's it there. I cannot read the value on that. Sorry, I keep getting my head in the way of this shot. I don't think I've got the camera set up very well, to be honest. But I'm not moving it now. You'll have to put up with it. Right, that's a 0.01, and the capacitor we're looking for is more than that. Just bear with me a second. Here we go. It is sorry, 0.1. So it is, I bet it's that one under there. It is, it's that one there. Now we did test it just with the meter and it was coming up as okay, but that is the one, so that is one capacitor I will always change, because if it dies, like I said, it can cause untold damage to the rest of the radio. Ooh. So let's get him out of circuit. There's that one there, so we can cut it there. pull him out. And where did I just cut that wire off from? There. And get it back onto there. Cut that off there. I think it was actually showing as still okay, but yeah, I mean the piddly little voltage that this tests at, that's actually still showing as a capacitor. Well, it's not showing as a resistor, which is the important thing, but I'm pretty sure if you put a lot of you put and get the if you as soon as you put 400 volts or 250 volts on it, that's going to start to break down, so we will swap that out. In fact, that other one I changed was that one there was probably okay. I just didn't realise it was on the filament side. Right, let's see what we've got here. Ah, there we are. Nice new one of these. Now these are rated at 630 volts, so they're actually rated slightly higher than the original capacitor. So I think those are only rated at about 400 volts. So unless you really know what you're doing, you can always go up on the voltage. Well, you can't go silly, but you can go up a little bit on the voltage rating. But unless you, like I say, unless you really know what you're doing, you shouldn't really attempt to go down on one. I mean, I have done in the past, for the simple reason I knew that the component that would say, you know, they've used a 400 volt rated component, but you know for a fact that that part of the circuit is only ever going to see, say, 150 volts, then you'd be fine using something that's rated at, say, 200 volts to replace it. But like I said, you really do need to know. You're better off if you're just starting out on this to either use the same voltage rating of capacitor or slightly greater than what was used previously. Right, so that's on there. That's soldered in position. Let's get the other leg up to where we want it. And then we'll connect this radio up, and we'll see. We can see if we can get it to play. I'll have to go through there because that's connected to that, so that'll work. Just hold that in position while I get that. Ugh. There, we got it. And I missed. Come on. There. Ooh. Basically, I'm trying to get hold of this wire and then I can pull it through. There we are. There we are. Bring that through and we can solder it onto that tab there. And that'll be fine. Yeah, because that's connected to that, that'll be absolutely fine. We'll solder it on that. Bend that around a bit. We can solder that into position. And then I'll be happy to give this radio a quick test, and we'll see if we've made any difference. At least now I'm happier actually switching the radio on for longer, because I'm not going to be risking cooking the output valve. There we go, that's soldered in position. Right, now like I said, we've only changed that which probably didn't need to be changed, and that which, you know, I'm happier about actually running the radio with that capacitor changed, because we're not going to risk damaging the output valve or the output transformer. Let's push that back in there so I don't damage it when I put the radio back down. And we will connect the speaker back up. That's internal speaker there. Ooh. Okay, we're going to need some kind of aerial. So obviously we haven't got the frame aerial connected up, which is built into the back lid. So let us find a length of wire we can use as a temporary aerial. In fact, I've got a spare, what's that there? What's that there? A bit of old speaker lead or something, that'll do nicely. And just get a bare end on that, and we can plug that in and use that as a temporary aerial just to see if we get anything. Get that up there. Put that in the aerial socket, which is that one. Probably see if we can get a better connection on the aerial socket. I'm not happy with that. Bend that way. There we are. Right. We've got the speakers plugged in. We've got a temporary aerial rigged up. Let's plug in and we'll see if we get any joy. Well, we've got a dial light. Just left it switched on. As you can see, we've got some valves lighting. Well, that didn't take much to get it going, did it?
In moments. When they tell you it's cancer, here's what they don't tell you. How to tell the people you live with, the people you love, people you can't. Feel.
Let's see what else we can pick up.
You feel me?
The Macmillan online community support each other 24 hours a day because we know what living with cancer is like. To join, search Macmillan online community.
Switch to BT Superfast Fibre this Black Friday and pay absolute.
Let's see what else we can pick up. If anything. Well, you only seem to be getting. We only seem to be getting gold. Which there are other stations around here that you can generally speak and pick up quite strong, but we seem to have lost it now. We did have gold then. Try just fiddling with that aerial wire. There we are.
Technology becomes complicated. Tomorrow, we believe that mobile phones should be simple, which is why our stylish use and feature clearer displays and louder sound. So if you're looking for a phone that's right for you,
Can we pick anything else up? Well, the radio is obviously going to need quite a lot more work, but let's see if we can get a better. I think half our problem is this aerial connection. Just see if I've got a better connector we can get on there. See if we can get a slightly better connection on the aerial, because I think that's what some of the trouble is. A big pot of various different connectors here. I'm sure I've got something that'll work on the aerial. That should. Well, that's a solder one. I don't really want to be soldering it. Let's see what else we've got. That'll work. Right, let me connect this aerial up a bit better, because I have a feeling that's one of our problems, is we're not getting a good connection on that aerial. And then we'll see if we can get a few more stations in. Tell you what, nice and quiet though. I can't hear any hum at all. I expect it to be a little bit humming. I mean, that's got its original smoothing cam by the look of it. An old TCC electrolytic there. There we go. Oh no, that's come out. Let me just see if I can get this to work. And it could actually, there we are. Right, let's give that a try. Oops, I just unplugged the no, that won't fit, damn. Let's give that one more try. Push that round there. Switch off a sec. And we'll have one final little go, see if we can get it to perhaps play again, play a little, get more than one station. Right in there. Plug that back in there. Our smoothing can's nice and cold. That's good. Ooh, get the mains lead from being trapped. We've got the aerial plugged in properly now. Let's see if we can pick any more stations up. I'm not in a good AM reception area here, but we should be able to pick up more than just gold. I don't think the output valve's very happy. I think it's well on the end of its life. We'll looks, and same with the rectifier valve, neither of them look particularly happy. Little bit of hum. No, I don't seem to be getting anything now. I wonder if we just plug in the loop aerial. I don't know whether this is any good actually. Let's give it a quick try. I'll switch off while I get this connected. It's a bit dodgy, obviously working around a radio like this. I've not got it on any form of isolation. The only isolation we've got is the transformer in the radio. Let's try connecting up the original aerial and earth connections. We'll see where we can get it to play then. Right, so we're using the original back of the radio, which has actually got the aerial coil built in rather than using an external aerial. And let's see if we get anything now. Oh, hang on. Hopefully we switch on there. I'll switch on that. So basically we're the same. Nothing there. I've obviously also probably got some somewhat dodgy valve contacts as well. We're not getting anything now. I think that's shortwave. Something there, but not. There we are. So basically the wave change switch, it's gone again. But basically the wave change switch is... There we are.
They are looking for an interim manager to take them to the end of the season.
That's with the controls all whacked right up. So I have a feeling that the rectifier and the output valves are very, very, very tired on this set.
What would you say to the players ahead of today? Now, another big...
There are stations there, but they are very, very quiet.
Interested in this, we've not been able to show it.
I'm not sure. So we should have long wave, medium wave and short wave, but I think that's probably short wave. Medium wave I think is in the middle. Again, we're not getting anything again. Well, the radio's not completely dead anyway, but it is going to need a lot of restoration. we're not getting anything now. Yeah, because that should be medium wave, where I was picking up stations before, but we're not getting anything anymore now. But we've ascertained that basically everything that's important in the radio works. The transformers work, the IF, the IF cans, everything like that, they all work, or else we wouldn't be able to pick up and tune the radio like we have. But I think we've got a lot of very bad connections, especially on the aerial socket. I think that's one of the major problems. I have a feeling that the valves are very, very, very tired. Like I said, we had that crank full open then, and yeah, it's audible, but it's not loud. It's had quite a hard life, this radio, I think. Like I said, someone's obviously worked on it in the past, not done a great deal with it, twisted on a new mains lead, and pretty much left it at that. And I think that's what I'm going to do now. I just wanted to see if I could get the radio to, if I could get it to play. We will probably restore it, because I quite like these little wooden, early 50s wooden sets like this. But it's not going to be a quick get it going job. So we've heard it play. It played a little bit. I ignore that capacitor there, because I probably didn't need to change that capacitor down there. But we did need to change that that grid stopper for the output valve, so that's been changed already. Really, with this set, it's going to be a case of changing out the other wax paper capacitors, checking the resistors, changing any out of tolerance resistors. But before I do any of that, I'll pull the valves. I mean, these valves, they've all got weird weird designations, because it's a Cossor and it uses Cossor branded valves, and they have their own numbering system. But these will be, you know, that will be like the rectifier will be, sorry, the rectifier will be something like an EZ40. The output valve will be something like an EL41 or an EL42. We should have an ECH42. You know, it's all standard stuff like that. It's just, like I said, Cossor branded their own valves, and they use their own valve numbering system. So what I'll have to do is pull all the valves out, and we will run them through the valve tester. I have a feeling that the output valve and the rectifier are going to be very, very, very poor. It's not a problem. Like I said, I don't have the Cossor branded ones, but I have ECH, ECH42s. I have EZ80s, so we could change them out for equivalents. That's not a problem. It's got a nice safe mains flex on it now. Electrically, I can't see a major issue with really getting it going. It's the dial string that's going to be a mare to sort out, especially being that the actual pointer itself's missing. It wouldn't have been so bad if the pointer had been left in the radio, but it's not. We've got a rubber drive belt round there. So yeah, it's definitely going to be restorable. We've heard it play, and the speaker sounds okay. Like I said, we know the mains transformer, the output transformer, the IFs, tuning condenser, all things like that are fine on it. It's just going to need a recap, and it's probably going to need a few replacement valves as well. Anyway, I'm going to leave it there for now. Like I said, I wasn't really planning on doing a video today. It was just a case of, oh, I've got 2,000 subscribers. I better put something out there. Hopefully I'll be able to show you some work on the new studio soon. There's not a lot to see just yet. apart from lots of cardboard boxes and bits of timber and sawdust. But as soon as I've got it a little bit more cleared out, we'll get back in there, and I'll actually show you what my plans are for that room. I was hoping we'd get this radio perhaps working a little bit better than this, but this video is already running on for an hour, and we've heard it play. We know what work we need to do to it to actually make it into a nice little radio, and it will make a nice radio for someone. This it's the fact that I'm going to have to restring it's an absolute mare. I hate restringing radio, especially when there's bits missing and it hasn't got the original stuff in there. But yeah, it's not a lost cause or anything, and we have that Philips to have a look at as well. That should be an interesting radio to look at. I might leave that for until we actually do have the new space to work in, where I can actually set things up a bit better. And I'm going to leave it there for now. I hope you enjoyed this little video on the Cossor 500, AC 500. So I'm going to leave it. Thanks for watching, and goodbye.